Welcome to the video on sine, cosine and area rules for any triangle. You will have used these in GCSE, mainly at grade 8 and 9. When you're going to do A-level maths, you need to really understand these and, more importantly, how they're derived, where they come from and why they work. So what I've done here is created a general triangle, and they have, it has three different sides, three different angles, and I've turned it onto one of its sides, and I'm going to label the side lengths with the lowercase letters A, B and C. Okay, A, B and C. And the angles opposite those sides are going to be capital letters of the same name. So that's capital A for that angle there. Okay, this is capital C, and capital B would be this corner here, which is the angle at the base here. All right, I'm going to drop down a vertical line that's perpendicular to the base. So it's a vertical line down here that meets at 90 degrees. Okay, and I'm going to show that as a dashed line because it's not part of the original triangle. It's something I've added in. Okay, so what I'm doing is dividing our original triangle up into two right angle triangles, and I'm just going to show that I've created a right angle here by putting a little box like that. Okay, so that's a right angle at the bottom there, and that's obviously a right angle in there too. And we're going to label this length here D, which is effectively the height of the triangle, okay, from the base. Now, we're starting with the sine rule, this one here, and we're going to prove that that works and how it's derived. So, using the fact that the sine of an angle is opposite over hypotenuse, okay, I can say that the sine of angle A is D over B. Okay, so I'm going to write here that sine of angle A equals D over B. And I'm also going to say that the sine of angle B is going to equal the opposite, which is D, over the length of the hypotenuse, which is A. Okay. Now, if I multiply this equation here by B, I get B times the sine of A is equal to D. And if I multiply this equation both sides by A, I get that A times the sine of B also equals D. Now, it's quite easy to see that if both of those two expressions are equal to D, then they must be equal to each other. In other words, B sine A must equal A sine B. Okay, B sine A equals A sine B. Okay, and I'm being careful to use lowercase letters where I mean a length and an uppercase letter for an angle. Okay, now if I divide both sides by AB, okay, so I'm going to now write those again, but this time dividing them both by AB, you'll see what happens. Okay, A sine B, and that has to also be divided by AB. Okay, so I've just done the same thing to both sides of the equation. Okay, so that's over AB, and that's over AB. Okay, well, in this first one, the B's will cancel to give me sine A over A, and in this one, the A's will cancel to give me sine B over B. So I have the result that sine A, okay, over A equals sine B over B. Now, I don't mention in there anything about sine C and C, but all I would need to do is just rotate all the letters round one place, and then I would easily see that sine C over C is also equal to sine B over B, and so on. So all those letters are interchangeable, really. Okay, so that's proving the sine rule, which is the first one here. Now the cosine rule is a little bit more tricky to prove, but we use the fact that we use the same triangle. What I'm going to do is I'm just going to break the length along the bottom up into two parts, okay? And I'll show you how that's going to work. So I'm going to call the part up to here, okay, is going to be, well, I'm going to call this bit here x. I'll write these on the inside of the triangle. Okay, so x is the length from there to there. So it logically follows that this length must be c minus x. Okay, so if the total length across the bottom is c, if that's x, the length from here to here must be c minus x. Okay, now I'm going to use Pythagoras' theorem. So I've done the sine rule in red. I'll do the cosine rule in blue, and I'll do it over here. So for the cosine rule, I can say that d squared must be equal to a squared, okay, minus c minus x squared. Okay, now what I've done there is I've just taken the right angled triangle that goes from here and here and here. Okay, so in that right angled triangle there, okay, so in that right angled triangle there, d squared plus c minus x all squared equals a squared. So if you rearrange that, you get this formula here. All right, and I also know, using the other right angled triangle on the other side, that's this one here, that that's the same as b squared minus x squared. In other words, d squared is b squared minus x squared. Okay, so I can say that that's also equal to b squared minus x squared. Okay, and both of those things are equal to d squared. Now, if I just work on this part here, I can say that a squared minus, now, if I'm doing this, I'm doing c minus x times itself. Okay, I'll write this out in full for you. And that equals b squared minus x squared. Okay, so because they're both equal to d squared, I can ignore that now, just as I ignored the d over here. Okay, and if I multiply out that bracket, or that pair of brackets rather, I get c times c is c squared. Then I've got minus cx minus another cx, so minus 2cx. And then I've got minus x times minus x, which is plus x squared. Okay, and that equals b squared minus x squared. Now, at the next step, I'm going to take out the minus sign, and the brackets rather, and that's going to change all the signs inside that bracket. So a squared minus c squared minus minus 2cx is plus 2cx. Okay, and minus x squared is minus x squared like that. And that equals b squared minus x squared. Okay, now, because both sides contain an x squared, Okay, I can cancel them out because I've got a minus x squared on this side and a minus x squared on that side. So I can just take those out by cancelling them. So I'll just strike them through to show that I've recognised that they appear on both sides. So I've got an expression now, or an equation rather, that says I'll put the b squared on the left and this on the right. I've got b squared equals a squared minus c squared plus 2cx. Okay. Now, what I need to do now is recognize that 2cx can be simplified because x can be written in terms of cos A and B. All right, so let me show you what I mean. If I look at this right angle triangle here, okay, I can see that the cosine of A is the adjacent over the hypotenuse. So I'm just going to write that here. So the cosine of A, the cos of A, okay, using ordinary right angle triangle trigonometry, is equal to the adjacent, which is x, over the hypotenuse, which is b. All right? That's a fact that you can glean from that diagram. And therefore, it follows from that that x must be equal to b times the cosine of A. Okay, so what I'm going to do is use that to replace the x here. Okay, so I've got b squared equals a squared minus c squared plus 2 times c times b cos A. All right. Now, it's not quite looking like the cosine rule as you know it, but it's about to. All right, because what I'm going to do now is just rearrange this formula. And I'm going to leave the a squared on one side. So I'm going to leave the a squared on this side and put everything else on the other side. So I'm going to have b squared. Okay, I'm going to add the c squared to the left-hand side. And I'm going to take away 2cb cos A or 2bc cos A. It's the same thing. 2bc cos A. And that is going to leave me with only one thing on the right, which is a squared. Okay? And there it is. Just the other way round. A squared equals b squared plus c squared minus 2bc cos A. Okay, so that's the cosine rule proved using two right angle triangles coming from our original triangle ABC. And now we've got the area of a triangle to prove. There's the formula. It's a half BC sine A. Okay, but it can also be written as, I'll just do this in green now. I'll just put the other versions here. You could write it as a half AB sine C. Okay, it's the same idea. We can just interchange the letters and then we just get a different variation of the same formula. Okay, and there's another one as well, of course, which is a half AC sine B, but you've got the idea. So let's prove that the area of the triangle is a half BC sine A. Well, if we go back to what we did on the sine rule, let's start with the area of a general triangle first. So a triangle is area is typically referred to as a half base times height. I'm just going to write it as words. Half base times height. Okay, that's what you're familiar with from the days before you learnt about these rules. Okay, now we can see on our triangle here that the base is C and the height is D. So in our example, it's a half of C times D, half base times height. But if you look at what we did earlier, so I'm taking you across to here, we said that D is the same as B sine A, didn't we? In our triangle, D is B sine A or A sine B. Okay, so let's just substitute the D with B sine A. So from what we did earlier, we can simply say that's equal to a half of C times B sine A. And that's it. Okay, that gives us one version of this. It gives us this one here. Okay, we just tend to put the letters in alphabetical order, so it's just swapping the C and the B over. So it's a half BC sine A. Okay, half BC sine A. So it's actually quite easy to prove that when you've done the sine rule, which we did earlier. Okay, so those are the three rules that you've used before at GCSE and may not have a full understanding of where they've actually come from and why they work. Okay, so learn them and get to know them, and more importantly, for A-level maths, understand where they've come from and why they work. Okay, in another video, I'll do some problem solving questions using those rules. Okay, take care.